Today's video will be looking at problem 141, linked list cycle. As per usual, the 3 steps solving any problem are 1. Understand, 2. Visualize it, and 3. Implement it. So let's understand it. Given head, the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can reach again by continuously following the next pointer. Internally, pause is used to denote the index of the node that's tail's next pointer is connected to. Note that pause is not passed as a parameter, so it's just hypothetical, or you just like kind of visualize it and return true if there is a cycle in the linked list. Otherwise, return false. So example 1, so we have a linked list 3204, but that -4 actually has a next value that is this 2. In which case, like, there is a cycle because 2 will go to 0, 0 will go to -4, and back to 2. Example 2, 1 points to 2, but then 2 points back to 1. There is a cycle, and here this 1 is not pointing anywhere, so it returns false. Look at the constraints. Number of nodes in the list is in the range 0 to 104, so up to 104 nodes. And the value of each node is between -105 and 105. Pause is -1 or a valid index in the linked list. And remember, pause is not passed, so you can doesn't do much with that. Can you solve it using O1, so constant memory? I think it's definitely possible, and I think it's the best approach will use constant memory. So let's try to visualize this linked list. So let's start off with the 2 pointer 3204. So you have this, and I'll just hide this guy for now. So you want to iterate, but remember this 4 points to 2. So when you iterate, you'll go there, you'll say next, and then we go to here. So I think the approach, the general data pattern that you want to be thinking about is this concept called fast and slow pointer. That is, very much related to just like 2 pointer problems, like we've seen quite a bit of those, where the idea is, let's say we use 1 pointer for our slow iterator. So slow will mean that it moves slowly, so by ones. And then we have a second iterator j that moves fast, so it moves it jumps in leaps of 2. So this guy starts here at index 1, but then its next value is actually 4, and then its next value will be 0 because it went to 2 and then 0. So that's its next position. If you then did that again, it would be 2 because it'll go 4 and then 2. And like with this kind of idea of fast and slow pointer, you can just keep iterating, one moving slow, one moving fast, and if they ever have the same value, that means that we have found a cycle. And if we find out that like next is null, so let's say this isn't cyclical, it's just 3204 and then 4 points to null. That guy jumped here. Well, in his next jump, he's gonna jump into the abyss, nowhere to jump to. So at that point, we can just say, hey, there's no cycle. So that's the visualization of it. So how do we implement this? And let me double check the constraints, how many nodes there are. So there could be 0 nodes, in which case we return false. There's no cycle because there's no even linked list. And let's set up our 2 iterators. So our slow iterator, we can use the head, and our fast iterator will be the next value. So once again, so I is the slow guy, and j is going to be here, the next value. And we're just going to keep looping until we find a cycle or reach a null value. So while slow and fast, we say while slow and fast because if either of them at the end of this iterative loop like returns null, like we just want to call it quits and say that there's no cycle, like one of these hit a null value and we want to stop. So what's the next thing? So we say if slow equals fast, because this would be a case where they're at the exact same spot. Say, we keep iterating, and then they're both at the same value. They're going to be equal. So we can just say return true. Then what else can we say? If so at this point we need to start we've had this case. So let's say this case is not the case. We need to keep going. So we can say if but now take the case where J is right at the end, and wants to jump by 2, but it can't because the next value is null. We want to check for that, or else we'll have some kind of error. So if there's no fast.next, return false. But let's say this doesn't trigger either, then we can just move our 2 iterators, one slow, one fast. So slow equals slow.next, and fast equals fast.next.next. And at this point, let's see how this does against our basic example. So return true. It figure out that it looped to 2. So at what point did this and it's -4. Let's just take this exact same example, and I went up 1, 2 went up 2, I went up 1, 2 went up 2, and here they are now the same value, so they coincided at 0, and this equal statement was shown to be true, so we return true. Let's see some more example cases. So those all pass, and let's submit the final thing. And so there you have it. That's the slow and fast pointer. It's like a variation on the 2 pointer. And thank you, and catch you later.